Welcome back everyone to GDC Live. I'm your host, continuing on through the day here at the Game Developers Conference in beautiful San Francisco. Like I said, I'm James Montemagno, and we're back with my good friends, we just met, best friends, Andrew from my favorite name for a group here so far, the Xbox Advanced Technologies
Group.
What is that? It's like, is it like some secret magical like group, like deploying rockets into space?
So not quite. We have two focuses. The first one is we're going to help developers basically produce the absolute best thing they can do on our Microsoft platform, specifically Xbox, and also on PC. Like, you get a company that's really close to hitting that 60. They need just to tweak it, especially for our hardware. We're going to come in. We're the ninjas that are going to come in.
Gotcha.
And help them.
You're the
get
secret
there.
ninjas at night coming in, hacking on the servers, hacking on the code to make it work.
And then the second group, the second thing that we're responsible for is basically the advanced part. We're trying to push the envelope as much as possible, come up with new technologies, new systems that we can then give to games that actually will help them, of course, perform best on our platform.
Makes sense, and especially now that developers building for Xbox are building for Xbox One and also Xbox One X, and often they're developing games for the PC as well.
Right.
That happen to run everywhere.
And like you see, we've got the whole machine learning is a big thing. There's a couple talks here at GDC about it by Microsoft.
So what all do you do on this group? What are you responsible for?
So my specialties are CPU, general systems, multi-threading, some file I/O. Or one way I explain to people is not graphics and not live.
Got it.
It's all the other stuff.
All the behind the scenes type of stuff that make the game run.
Make the game actually fun, run well, as opposed to just look pretty.
Got it.
As I say for the graphics.
Yeah. And what we want to talk about today is how we're kind of pushing the envelope on the back end side of things.
Correct.
We were talking earlier with Ed about Git and big repositories and large files, especially when it comes to assets. And as a game developer, I know in the past, not anymore, but in the past, and as an app developer today, I know that when I'm building an app, when I'm building a game, it's more than just what I deliver at the end of the day. I have backend services, analytics, crash reporting, I have peer-to-peer networks, I might be running servers on some cloud that's making all this stuff happening, leaderboards, I mean, it's complex.
Right.
So can you talk about what do you see when people are building games? What else are they deploying and how do they deploy that code for their back-end services?
So I guess the big thing is, so you figure, first of all, the amount of code and such that they're putting together, it's easily 50% or more of the entire game platform that they're putting up into the cloud, such as what you're talking about, gathering telemetry. Telemetry is huge, especially when you're talking about all the microtransactions, DLC, because you want to figure out what's best for that kind of thing. But another big one is their actual servers they're running in the cloud. Because financially, a company doesn't want to actually buy their own hardware for their servers, because what happens is the natural ebb and flow of the player base is going to change. It's much easier to go to, say, Azure and basically pay for exactly what you need and run their servers that way.
And you need to scale up really fast.
Right.
You have a game release, you're at your peak, things are going up and down, big update maybe, spike again. And you can't just randomly go out and buy a bunch of servers.
Yeah, like I used to work on MMOs, and the natural lifetime for any MMO, anybody's ever looked at them, is, initial release, your player base just goes like this, and just the natural, it starts to tail off over the years, which happens in any game that's out there. But as you said, new update came out, we got to tick up and tick down.
So how can the cloud actually handle that? Like, how does that work? From a game developer side of you, like, what does that mean?
The big thing is, so they're going to choose, say, what type of instance they're running on, what type of hardware they need to run one of their servers for X number of players. Just to say they need one server instance to handle 1,000 players. But then they can dynamically adjust that based on what their actual daily player usage is. And part of that actually is over the day, it naturally ebbs and flows just by the time of day.
Yeah.
Like as everybody comes home from work, you'll see a pop-up, and maybe your player base was going to double or triple, So you need to bring more hardware online, but then at weird hours of the night, no one's playing, so you obviously don't want to pay for that hardware during that time.
And I guess another challenge is these games are global. I think
that actually adjusts those numbers because you have to worry about the whole time zone thing.
Yeah.
And there's actually, it's kind of funny because when we were tracking those, you'll actually see downticks based on major events going on. Like you look at the US one, it's like, oh, it's Super Bowl Sunday. Guess what? Nobody's playing your games on that. So you don't want to pay for the hardware during that time.
And you need hardware everywhere. If you're making matchmaking that's really popular in Europe, you probably want servers in Europe and you want them in the US, you want them everywhere.
Yeah, you want them as close as possible to the players, reduce that latency between them.
So when I'm deploying this code in the back end, and what we kind of wanted to focus on was, I would say the trials and tribulations and awesomeness of deploying stuff into a cloud and how servers work, and that's a lot around hypervisor, I would say. Is that the right way of putting it? The hypervisor technology is enabling of servers to do this work?
So in the underlying hardware that basically your cloud service is running, they're running what are called blades, or what we tend to call them, just those individual rack-mounted machines.
You see a server, you see all these lights, and there's these big blades essentially that go down, that on, go, go, go.
And then your cloud provider, they're going to do their dollar costs and what works best for them for that kind of hardware. Those tend to be pretty powerful. But then based on whatever instance type that you want to run, like say, A0, A1, D0, D1, D2, you get a percentage of that hardware to match basically what instance that you choose to pay for. But the way the cloud is going to run, each one of those blades is running on a hypervisor, which splits up that hardware across multiple operating systems or instances, all running on one piece of hardware.
So there may be one piece of hardware, but you're saying there's like a bunch of versions of Windows and things on it.
Say you're running, I don't remember all the exact Azure instance types. Let's just say you're running
There's a lot of them too.
Yes, there are. And you can pick exactly what works best for you. Like say we have one of them that only has, basically say you get 2 CPU cores is all you want for your server. But it's running on a piece of hardware that has 32. So obviously we can run 16 different individual servers on that one piece of hardware, but each instance is only going to see 2 CPU cores.
Got it. So for me as a developer, I'm developing my game locally, I'm running my local servers, I'm kind of debugging. It obviously is a very different experience when I deploy it into Azure. So what are the trade-offs? Is there some way of emulating that locally so I can get a better experience, or can I just expect that it's going to run great in the cloud perfect?
Well, of course, it'll run great on Azure. So underlying, for instance, Azure uses underlying, they're going to use, of course, Microsoft's hypervisor, which is called Hyper-V, which is included with Windows. And so the individual game developer, they can create their own Hyper-V virtual machine on their local desktop that try and give it basically the same parameters as what they're going to basically pay for their instance. So they can test everything locally, make sure it all works to get the performance they want. And so then when they take their package, upload it to the cloud, they already know ahead of time what their performance is going to be, they've debugged it, it works to their expectations. And then now they just hit the scaling that they need based on their player base.
Got it. And I'm very used to Hypervisor because I do some Docker, essentially containerization of images for backend services, and I'm able to essentially run kind of Linux on my Windows machine to deploy it into, because it could be a different operating system that's running my code, I guess, too.
Correct. As far as the operating system is concerned, the virtual machine, it's virtualizing the hardware. And so once you do that, you can run any operating system you want. If you're going to take it, it's an Intel architecture, you split it out, it's just going to give you basically virtual Intel chips. As you've got an Intel operating system that runs on Intel chips, it's going to it'll run within the virtual machine.
Got it. So I feel as though on my local machine, let's say my Surface Book 2 here, I got an i7 in here, pretty great. I got 16 gigs of RAM. I feel as though maybe the cloud is a little bit more powerful than this.
Just a little bit.
Just a tiny bit. So how can I emulate the cloud on my machine if I need to spin up something with 128 gigs of RAM and I have all the cores. We like to say all the
So
RAM.
you want one of the really big instances where
Yeah.
you do have, I want 32 cores, I want the dedicated GPUs.
Want it all. I'm gonna spend all the money. Give it to me.
Well, you should probably go out and buy your own blade that you can put in local in your machine.
Got it.
So you can test locally if you want. Or, you could always go ahead and actually test and debug within the cloud itself, within your instance, as opposed to still buying your own hardware.
Yeah.
Your iteration turnaround time will be a bit longer because obviously it takes you build your new copy of the game, you have to then upload it somewhere. The internet's not instantaneous.
Yeah.
That's the only thing you're really speed-wise.
So I can still actually try to leverage a bit of Azure to see what it's going to be like on these big machines if I don't have these big machines. But that's also the big benefit of cloud is that, I know what the performance is like on this, just wait until I put on 32 cores.
Well, also to give you another thing, so like again, when my previous job was working on MMOs, we do a lot of, basically we want to test it, load testing on the server.
Yeah.
So what we would do is, we need 100,000 users to simultaneously log into the server. How do you do that? Because obviously we can't get 100,000 users.
How do you do that? Yeah, you can't do it on this, that's for sure.
We made scripts that started up as many instances as we needed in the cloud and just had them all pound the server basically. So we had 100,000 users logging in within 5 minutes and see how the server could handle that.
Got it.
If the server handled that, we were golden, but we had to use the cloud to get those 100,000 users to log in.
Well, it's pretty awesome that you can do that though.
Yeah.
It's like you're go ready essentially, because I talk to a lot of developers and they're almost never ready for that day one, right? They're like, how are the servers gonna, how am I gonna react? Am I gonna have auto scale? Should I put everything at 100%? And I think being a little preemptive sounds like you can take this server workload and test that stuff out.
Well, you definitely want to do load balance testing on your servers because it's a horrible experience. Day one, you put your game out there, you figured, only 200,000 people are going to log in the first day, but wait a second, it's super popular. You just got 1 million people trying to log in on your day of launch and just your servers fall over. And that's the worst press you can have.
Yeah. So if I'm deploying a bunch of code to my backend, I've tested it here on my service book, it's not the same. It's not, even if I'm the similar setup, it's not the same hardware. So for me as a developer, are there complications when I deploy it? Like, are there issues that I may run into?
Yes. So running within a virtual machine, the hardware has been virtualized. Well, that's why they call it a virtual machine.
Virtual machine, go figure, it's in the name.
But also based on, again, based on what instance type you choose, you're basically given a certain performance profile. That's what you're paying for. But if you're running on a pretty high-powered blade, you're going to get a percentage of that, and you actually may even end up sharing. Say you want a 2 CPU system, but as newer generations of hardware come out, they're obviously faster than what you originally had. Yeah. And so what can happen is you may be sharing one of the actual physical CPUs with a totally separate virtual machine.
Oh, interesting.
And so but you're constantly getting at least the performance that you requested initially, but over the years, it's running on faster and faster hardware, so you're actually getting a smaller percentage of the CPU time, but you can still perform the same amount of work because it's a faster CPU. And so the issues you run into is, the way it does that is through something called time slicing. And so the hypervisor is going to...
explain that a little bit, because that just sounds futuristic, time slicing.
So what's going to happen is, the hypervisor is going to say, okay, well this particular virtual machine gets 10% of this CPU core, this other one gets 60%. And so it's going to sit there constantly switching between the two. And you have to kind of take that into account that may happen on you, because you don't get notification when it happens.
It just happens.
It just
cloud.
happens.
It's always upgrading, ever on, magic.
You can, your clocks will all still be correct, obviously.
Yeah.
And even though you're only getting the 40%, it's newer hardware, so you still can perform the same amount of work.
Got it. Okay.
But the big issue that happens that games might run into, so an average game, they want to run at 30 or 60 frames per second.
You kind of want to be locked in at one of those
So let's say you're running at 60 frames per second, so you get 16 milliseconds of time. Well, Hyper-V runs on a 10 millisecond time slice. So what happens is, if you're getting 40%, you're going to get 44 milliseconds. Then you're going to lose 6. It's just going to be gone.
Oh, okay.
Then you'll get another 4, and what happens is your clock jumps when that happens. And if you don't know that's going to happen, and you try and take things into account, like it happens right in the middle of your frame, and all of a sudden your clock jumps, and then your physics may go crazy on your server if you're not if you don't know that's going to happen.
So how would I even attempt to debug that, or even attempt to tackle that type of scenario?
Well, the first thing is to use Hyper-V on your local machine, hopefully create that situation there.
Okay.
You can actually do that when you set up your virtual machine, because you can, basically you choose the parameters of the virtual machine, and just take that in relation to the actual hardware, like your Surface Book that you're running on. Obviously, if you give it, you want to give it more power to that virtual machine than is on the hardware, it's going to try and do the time slicing for you.
Got it. So
that's the first step, is try everything local.
So you're saying I would set up a Hyper-V image that's more powerful than my machine? Or?
That should work for you.
Okay.
I'll be honest, I haven't actually tested that.
All right. So there's something I can do at least locally to attempt to
Right, one of the parameters when you set up your Hyper-V instance is, I believe there's a percentage in there that you can give it. So like, you basically can say, oh, only give it 50% of a CPU, of a physical core, that kind of thing.
Got it. Okay. And then what's the other way around it, essentially? Is there...
The other way is basically start an instance up in the cloud and actually start testing up there.
Okay.
But since you know the time slicing is at 10 milliseconds, take that into account in your design. You can actually, it's a very regular 10, you can actually figure out, you can align your code to that 10, because you can determine when it happens.
Oh, I see.
I mean, after the fact. So when you first start up, you can run some code where you effectively sit there in a really tight loop, checking the clock. We use a query performance counter, which gives you a high performance clock. What happens is, as soon as you lose the time slice, and then when you gain it back, your clock is going to jump. And it's very obvious when you see this happens. So right when that jump happens, you're at the beginning of your time slice. So that's when you want to start your frame. And then try and keep, basically that's when you start your frame, which will then give you the least amount of chance of it happening, basically the slicing happening in the middle of your frame.
Okay, nice. So if I'm putting code up there, what types of logic am I actually putting in the cloud? So when I'm building a game and I'm thinking about moving some logic to the cloud, what does that mean? You know, what are we seeing developers put up there?
So it all depends on what type of server you run. There's the two major ones. So if the game is, there's either a dedicated server or what we call peer-to-peer.
Okay, and what's each of them? Walk me through each of them. I'm brand new, pretend I don't know anything.
So
I'm not in the Xbox Advanced Technologies group, okay?
So your dedicated server, that's effectively, the server is actually running the game code.
Yes.
It's validating what the player's doing. It's probably one of the best ones out there for anti-cheat, because in the end, the server is the law.
Yeah.
If the server says you can't do anything, you can't do it.
So if 2 bullets are fired, the server is the one that's deciding
whether it actually hits or not in the long run.
Got it.
And so the clients tend to be less, they don't have to be as powerful, which helps you hit a higher frame rate, because you may be doing your full physics in the cloud on your dedicated server.
Oh, interesting.
And actually, so that's basically what the dedicated server is for.
Yeah.
You're going to find that especially in any of these high performance games, especially for trying to do any type of anti-cheat with esports, that kind of thing.
Got it.
Because with the dedicated server, you, the developer, has 100% control of that title.
Got it.
And sometimes, some titles will actually let individual people run their own dedicated servers. More if they just, other players just want to do their own thing, just let them.
Yeah.
If they happen to want to run a gray server that lets it, that's fine. It's in their own little area. But so it's not interfering with the other players that you can have a problem with. The other type of system is peer-to-peer. And in that type of system, there is no dedicated server. So each individual player and their client is doing effectively all the work and simulating everything.
Oh, okay. Yeah.
And then each of the clients tries to stay in sync with all the other ones. And of course there's code to handle if they get slightly out of sync, getting them back in. determining who's authoritative. But what a lot of there's one core issue with that, which is NAT traversal, which is you can have a very strict NAT, and so it makes it harder. Basically, if you and I want to talk peer-to-peer, you kind of need a connection to every other player in the game.
Yeah.
But there may be an issue based on the way my network is set up in my house. I can't talk to you.
Oh, I see, yeah. So if I'm blocking a bunch of ports or I'm doing something weird on my network, I have crazy setups and child control over everything, and at that point, I just can't talk to you directly.
Right, and so what happens in that case is, so I may have to talk to a third player, and then the game has to do its logic. Okay, that third player then has to route my messages to you because you can talk to them. So the way a lot of people are getting around that now is what's called a collector distributor system.
Okay.
And you run that in the cloud because everybody can talk to the server in the cloud, and the server can talk to everybody else.
Because if they're online and they're on Xbox Live, they're online, they can talk to the Xbox Live servers, yeah.
Well, the big thing is, so like with the strict nets, if I'm the one who actually opens that network connection, it's okay.
Yeah.
You can't open the connection to me, but I can open one to like you or something. But so everybody opens the connection up to that cloud because everybody can see it on that instance. So now that the cloud instance can now talk to everybody else. And so what it does is each game client will send their network messages up to that cloud instance, which will then collect them all, the collector part of the collector distributor, and then distribute them out. And sometimes there's extra logic in there. They may put some dedicated server logic, but like they can take all those messages, kind of combine them to make smaller packets. They can help reduce latency that way if they need to.
So really
whatever works for their title.
Yeah, some of the really advanced networking that's going on.
It gets a lot more complicated.
Yeah. I imagine. I was pretty lucky. We did mostly all, I forget what we did. We did some, I think we had a dedicated, we did the second route, which someone was the dedicated server, and that was the kind of master of everything. So
yeah, like some titles will still use a dedicated server system. Like one I worked on, it was a dedicated server system, but actually what was happening was it looked like peer-to-peer, but they chose who had the best hardware. It was a PC game, and that particular one ran a separate kind of process that was the dedicated server, but then they had the client and just everybody
talk to it.
It was a separate instance of the game that was their server. It just happens to be, oh, you've got the best hardware. Guess what? You get to be run the extra code for that server.
Yeah, you got the best internet, you got the best hardware, you win. So,
but now you can do that all basically within the cloud. This is all before the cloud stuff was available.
We've talked a little about hypervisor and what that means to put the code up, but what does it mean to actually scale? Because I remember watching some of the early Titanfall promotional videos. I was a huge Titanfall fan. And the video, the game dev was like, you throw a server here and a server here and a server, like servers everywhere. There's so many servers, right? Everyone just throw it around servers. What does that mean? And is there implications of spinning up different server with the hypervisor stuff? Like as a game dev, what should I be aware of when I'm spinning up new servers randomly?
So the first thing to be aware of is where the server is physically located. I mean, obviously we have data centers around the world. Speed of light's a constant.
Yep.
And it's actually, you get too far away from your server, that takes into account, that's going to add latency for you.
Got it.
You get pretty serious latency if you're here in the US talking to a server in Australia.
Yeah.
So you obviously want to spin up a server within a data center that's close to the players.
Got it.
So you'll tend to be, like I've never played Titanfall, I'm going to be honest, I've never looked at it.
It's a good game.
I looked over some shoulders, that's
Big
about
fan.
it. But you're going to try and matchmake with players that are physically located closer to you to help reduce that latency.
That makes sense. And you can then use your telemetry to say, oh, I'm really noticing a spike right now in California because everyone's here at GDC and now everyone's playing Titanfall or playing something else.
So you want to start more servers up within the local data center that's close to California.
Got it. And when I'm spinning up new servers, should I then ensure that if I'm running one type of game logic, how important is it that I'm running that game logic on the exact same like hypervisor hardware? Or does it matter?
So it won't matter what the back-end actual physical hardware is. It's entirely what instance type you've chosen for your server. Every one of your servers will get the instance type you chose, with the performance parameters that you chose for your server.
So when I'm deploying code, make sure that those are the same.
Right, which should happen because that's effectively what you've asked for.
Hopefully, yeah. Got it, okay,
That's
cool.
what you're paying for.
That's what you're paying for, gotcha. All right, cool.
So,
is there any other really key takeaways of deploying to Azure, lessons learned that you can talk about from the Xbox Advanced Technologies group?
So I do have a really funny one
hit me.
of a studio we worked with. So with this 10 millisecond time slice, so they had a problem with their server, which was their server was running at 150 frames per second.
Oh wow, okay, yep.
So because you had this time slice, what happened was sometimes it'd be in the middle of a frame, sometimes it wouldn't. So they wouldn't have a consistent frame rate. So they'd hit, sometimes they're at 150, sometimes they're at 75. And so it was all over the place. So it's something to take into account. It's actually impossible to hit a steady frame rate over 100 due to that. So that was one of the easiest things to fix. We simply said, make your code slower.
How do they do that? They just like introduce, like,
They
down.
They just basically said, okay, between each frame, we'll just spin around and just wait. Because again, they could determine when a frame started.
Got it.
And so they just said, okay, I'm going to start a frame now. They know if they can run 1 or 2 frames within that group, and they'll just choose to run 1 or 2 and then just wait till the next one starts.
They
so they just kept, they just did one, and they just kept it at a perfect steady 100 frames per second.
Nice.
And they were fine, they were happy.
Nice. Well,
that's the big thing.
Yeah. Andrew, this is great because, is there any, in the final few minutes here, any places to learn this stuff? Like where do I go as a developer to learn about Hypervisor and how to best deploy? Just our docs, docs.microsoft or?
MSDN.
MSDN?
We've got full descriptions up there of how Hyper-V works, how to work within it. One thing I did forgot to mention, something to watch out for, because the hardware is virtualized, certain instructions are virtualized as well and can be more expensive.
Okay.
A lot of games like to read the timestamp directly with this RDTSC instruction. That's going to be virtualized, so it's going to actually be a lot more expensive. Just use our actual Microsoft things. There's a function, query performance counter.
Got it.
It'll be fast for you.
Yeah.
You can ask it what the frequency is. It'll be right.
Awesome. Is there a
That
theater
kind of
session here later at GDC that's
There will be one Friday.
On Friday? Okay.
Which I'll cover a bit more detailed exactly what's happening with the slicing and how to work around it and how to measure when it's happening.
Beautiful. Well, you can find that all on Channel 9 afterwards. So if you're here at GDC, come on down to the Azure area. Love to have you. Yeah. Andrew, thank you so much.
Well, thank you
for joining us. Yeah, and everyone get ready to deploy all your code up to the cloud and stick around for even more live from GDC.